2015 question 10. Two cars A and B. They start from rest and we're given their velocities t squared and 6t minus 0.5 t squared. And we're asked to find the speed of each car after 4 seconds. So when t is equal to 4, the velocity of A is equal to 4 squared, which is 16 meters per second. And the velocity of B is equal to 6 times 4, which is 24 minus a half of 16, which is 8. So 24 minus 8 is also 16 meters per second for the velocity of B after 4 seconds. The distance between the cars after 4 seconds. So distance, we're dealing with distance and time. ds dt, which we know is equal to velocity. S is equal to ut plus a half at squared, and then differentiate. So we have A, we can take them separately here. So we have the s dt for A is equal to t squared. So the s is equal to t squared dt. If we integrate these, it's after 4 seconds, so between 0 and 4 for time, and we'll find s. So integrating the s, we're going to get s, which we know is just going to give s, but if we do it technically correct, t cubed over 3 for integrating t squared between 4 and 0. So we're going to get s, or s minus 0, is equal to 64 over 3 minus 0. So the distance for A is equal to 64 over 3 meters. We do the same for B. ds dt is equal to 6t minus 0.5 t squared. ds is equal to 6t minus 0.5 t squared dt. You will have time in an exam to write out every step. So if we integrate both sides and find the distance in the first 4 seconds, we'll get s. You could skip a stage if you wanted, but don't. 6t squared over 2, 3t squared, there you can, minus 0.5 t to the power 3 over 3. And that's between 4 and 0. 0 won't give us a value here, so we're going to get s equals 3 by 4 squared is 48. 3 16s minus half of 4 cubed is 64, so half 64 is 32. 32 over 3. So s is equal to 348 is 144 minus 32 over 3. So we're going to get the distance for B to be 112 over 3. So the distance between them is 112 over 3 minus 64 over 3, which is 36, and 12, which is 48 over 3, which is 16 meters for part 2. And then part 3, on the same speed time graph, sketch the speed of A and the speed of B for the first 4 seconds and shade in the area that represents the distance between them. So this is your kind of junior cert knowledge. We have 2 quadratics here. A is positive t squared, so it's your x squared, your normal x squared graph. And B is minus t squared, which is an inverted or upside down, so we just want them to intersect. Here's my intersection. That was the start of the question. They were going the same speed. You can see when t was equal to 4. So down the bottom we have time. Up along the side we have, I'll just extend my graph in red. We have distance 16. It was distance and not speed, wasn't it? Speed time graph. Speed time graph, hang on. The 16s are the same anyway, so we've got our time and our speed. After 4 seconds, they're going 16, and that is the end of this question. And if you thought it was, you would lose 5 marks because you were asked to shade in 2. So this shading got 5 marks, the sketching of it got 5 marks, and the rest of the question got 15. So don't forget to do a tiny bit of shading.